Hello, everybody. Uh, my name is János Mátyás. Today we're going to talk about Docker-based Hadoop provisioning pretty much anywhere. As you know from yesterday, since Monday we've been acquired by Hortonworks. So we're working for Hortonworks now. So what we're going to talk today briefly, so after the short introduction, we're going to go through about goals and motivations, the technology stack, how we do Hadoop provisioning pretty much anywhere, how it works, what are the results, and what's the future plans. And then if there is time at the end, then we can have a Q&A session and a demo. Hopefully, most of you have seen the demo already, the Dev Cafe, because we've been running these Cloudbreak demos yesterday and today. If not, there is going to be a WebEx at the Hortonworks site, I guess on May 19th or something like that. So if you haven't seen Cloudbreak and there is no time at the end, then make sure you check on that WebEx. Okay, so the funny story for us is that so we never wanted to work on Cloudbreak and Periscope. So actually, we started to work on a big data pipeline application last year in February when we started Sequence IQ. And we've been provisioning large clusters pretty much anywhere. We've been obviously developing our laptops, then we needed to push to QA, then we needed to push to UAT, to prod. So we use lots of cloud providers, and we needed a common way, like how we can automate this whole process, how we can simplify this whole process, because provisioning Hadoop clusters is not that easy. And obviously provisioning a full stack Hadoop clusters. So our goals and motivations were to, first of all, to provision a full stack. And what I mean under full stack, pretty much all the Hadoop components, HBase, Kafka, you name it. We've been using pretty much all the components, and we wanted an automated way to provision this. And obviously, we wanted a unified process. Our other idea was like we wanted to use zero configuration, especially in the cloud, where you don't know anything beforehand, you don't know the IP addresses, you don't know DNS names. We wanted to have a zero config approach and come up with a cluster in a couple of minutes without configuring anything beforehand beside the services. As I said, we wanted to use the same processes pretty much everywhere, and we needed to provide tooling. UI was the last thing which actually we did, so we started to first internally to make a REST API, a secure REST API using OAuth 2. Then obviously, we are pretty much DevOps focused, and we use the CLI. We created a CLI share to provision these clusters. Obviously, these clusters had to be multi-tenant and secure, so welcome Kerberos. And then we wanted, since we've been pretty cost-aware, being a startup, we did something to auto-scale clusters up and down. So we've been scaling clusters from 200 nodes up to 1,000, and shrinking it down to 10 nodes over the night, and then in the morning came back around 200. So that were our main motivations. So the technology stack we used, the main components we used in order to basically solve these problems, which we had and we never wanted to work on, were Docker, Swarm, Consul, and Apache Ambari. So I'm going to go through all these individually. And then we can enter in details. So Docker, I guess, how many of you have been playing with Docker before? Yeah, that's what I'm expecting. Last year I had this session in San Jose, and not too many people raised their hands. So yeah, Docker is getting traction. So anyway, Docker, so for those who are not familiar, Docker is an extremely lightweight virtualization. So it's pretty much think like a VM, but a lightweight version of a VM. It's very lightweight and it's portable, so this is something which was pretty appealing for us, like we could move containers here and there. The other thing, again, because of the automation, and because we were provisioning to different environments, we wanted to build it once and run anywhere. Like, obviously, Java had this promise years ago, but we all know how it works. It looks like with Docker, this problem is pretty much fixed. So we've been using the same containers on QA, push up to production, so there is no change. So there are no more things like it works on my machine or it works on my computer. Once you got a Docker container working on your laptop, and if that container gets pushed to any environment, you are pretty much sure that you got consistency across QA, UAT, prod, and across different Linux distributions. Ease of packaging was something which we wanted to add. Obviously, Hadoop has lots of components and services, and packaging them in an easy way, that was something which was high priority for us. Yeah, obviously we wanted, as I said, everything automated. Like for example, we've been pushing up clusters from Jenkins, set up a 200 node cluster. When somebody started a GitHub push, for example, then we're tearing down. We had to script this, and the other appealing thing for us was that it's isolated. So in the same environment, actually, you could be running different containers in an isolated way. Okay. This works. So how it works? So many people think that actually there is big magic behind Docker, but actually there is no magic. So all the components which Docker is using has been there in the past 10 years. So pretty much is using the C group and namespacing capabilities of the Linux kernel, which they've been there for a long time. The only addition is that Docker introduced a layered file system, which basically you got a couple of layers, and for the end user represents a cohesive file system, but everything is layered underneath. So as you see on this image, pretty much there's a difference between a VM and Docker. So the Docker containers are using basically the same kernel. There is no overhead, there is no hardware emulation needed, and obviously you can span up way many containers on the same kernel as you would span up VMs. You can reuse basically the same kernel and reuse the same libraries. So now we can start. We have an option how we package HDP or how we package Hadoop on any environment. It works on my laptop. It works on the cloud. It works on a bare metal. So we needed a way to automate building a cluster. So you need to push this container somewhere, right, in your preferred environment. So initially we started to use on cloud providers. We had on each and every cloud provider, we had a proprietary mechanism, like user data scripts, for example, on AWS, where we did the initial bootstrapping. Now with Swarm, that's not needed anyway, and actually it's getting standardized, and in a way that the same way we can push Docker containers to any cloud provider and bare metal using Swarm. So what's Swarm? So Swarm is pretty much a native clustering for Docker. So imagine you got these Docker containers, and you got a Swarm manager which can launch containers remotely on different VMs or different bare metal on different hardwares. It's distributed. And the good thing about Swarm is that pretty much it's using the same API as Docker. So you can talk to Swarm. Actually, Swarm is a Docker product. Sorry, I haven't mentioned that. It's using the same API, but has these additional features. So how Swarm works? So the main concept is you got Swarm managers. You can have, obviously, for AJ, you can have multiple Swarm managers, and you got Swarm agents. So Swarm agent is running on every host or every VM or a cloud VM or bare metal. Now, the Swarm manager can talk to these agents, and obviously, to form a cluster, to form a Docker cluster, then these VMs or these agents, these Docker containers, they need to know about each other. So Swarm has a discovery services inbuilt. So by default, you've got 2 or 3 discovery services, which can use for container discovery actually, and you've got advanced scheduling. So what does advanced scheduling mean? In this case, is that Swarm is pretty much aware of your resourcing needs. So you can set up different strategies. So you want to start up different containers remotely on a couple of hosts, and currently you got 2 options. You got a random option, which you say Swarm spins up clusters anywhere, and you've got a bin packing options where actually you can say my container needs 2 GB of RAM, and Swarm is going to take care to launch that container in a host which actually can provide you that resource needs you have. Also, you can label nodes and use these labels in order to for a Swarm manager to start containers only on hosts which are labeled. So for example, you can label hosts like high CPU labeled nodes, and you can span up containers which they have a high CPU demand only on those VMs, and only on those bare metal machines which do have this capability. The other nice feature is about, yeah, you've got a health check, obviously. You need that. You need to know which agents are, which nodes actually are healthy. So you don't want to schedule containers on those nodes. You got affinity. So for example, you can set up, if you got dependency between your containers, so if you got two containers which are linked together, so Docker allows you to link containers, or Docker allows you to share network between containers, or Docker allows you to share volumes, for example. So if you got this kind of dependency, Swarm out of the box is gonna know that, yeah, this is affinity between these containers. I'm gonna schedule them together on the same host, or the same bare metal, or the same cloud VM. Since this is at high level how Swarm works. So now we've got the option. So now the Hadoop is packaged in HDP. Now we can launch pretty much anywhere these HDP containers. Hadoop has got lots of services, right? So we need to know where everything is dynamic, so we don't know anything before, and so we need to know what's running where, whether it's healthy, where it's running. So in order to fix this, then we use Consul. So Consul, it's pretty much at a very high level, it's a service discovery, service registry tool with a couple of nice features. Obviously, there are lots of service discovery, service registry tools like Zookeeper, ATCD, DoZerd. The main reason why we choose Consul, first of all, is because the DNS capabilities. So we needed DNS capabilities for those services. The other reason is that it gives you out-of-the-box health checking for those services, and it's not just a service registry, but actually gives you service discovery. Key value store, pretty much all like Zookeeper has a key value store as well, but as Consul, HCD has one. But the other important thing for us was that, especially if you are launching production Hadoop clusters and across different data centers, Consul is data center aware because of the protocol which is using underneath. Excuse me. So how Consul works? Same like Swarm is the same concept. You've got servers and you've got agents. An agent is pretty much a long-running process, a long-running daemon on every host. So every Hadoop host in our case is running a Consul agent, and those agents, most of the Consul agents are clients. So what I mean under clients is that the Consul clients are actually talking to Consul servers, so that's their main role, pretty much forwarding all the requests towards the server. In order for Consul to work, the most important thing is that you need to have, pretty much like in all service discovery systems, you need to have a consistency, and that consistency is provided by the Raft protocol. So you've got a quorum of Consul servers, which form pretty much dynamically they figure out which is what nodes are the servers. What's underneath? So this is the Raft part of how Consul is how Consul forms a quorum. There is another protocol underneath Consul which was pretty appealing for us, is the Swim protocol for the gossip. So there are lots of service discoveries who are using different kind of approaches. In the cloud, usually by default, like broadcast, multicast, it doesn't work. So you need something which works on UDP or TCP unicast. This is how Swim works. And the other thing is, the other appealing stuff is that it's a gossip-based protocol. So because of this, all the nodes, like for example, when a node comes in, or when a node leaves the server, the Hadoop cluster, or when a node fails, then instantly that gets registered in the Consul server, in the Consul service registry, so we know pretty much all the time the state of the cluster. This was pretty important for us because we are building auto-scaling clusters, so we never think in static clusters, because actually what CloudBrick and Periscope does is orchestrates allows you to provision not just static, but dynamic clusters. Also, is this obviously is decentralized and fault tolerant. So if a server fails, then obviously there is going to an election process starts. Usually you need to have like 3, 5, or 7 servers, but up to a couple of thousand nodes, 5 Consul servers are far enough. So we haven't seen a need to have like 7 or maybe even more. Obviously, it has to be an odd number. The important thing of Consul is that basically it's always, so it gives you consistency. So every time on any node, somebody asks like, where is this Hadoop service? What's the state of the Hadoop service? What's the state of this node? You need consistency. So every request has to be consistent and came back at the same time with the same answer. So obviously it prefers consistency over availability. The other interesting thing with Consul is that basically beside the REST API, it gives you a DNS interface. So it's pretty easy on a Linux node to use dig to figure out where one service is running, what's the state of the service. So you've got multiple protocols. It's secure. You can set up ACLs. You can set up TLS. That's default. Pretty much that's default for Swarm, and actually that's default for that works for Docker as well. So I did not mention, but actually we use TLS. The other interesting thing in Consul is that, as I said, it uses key value stores. So we are using the Consul key value store quite a lot. So we are putting things in the key value store. We are removing things. And Consul allows you to configure watches. So for example, under one key, if the value changes, then an event can be triggered. So there is a Consul event which is triggered, and then you can do whatever you want. If you have to do something based on that event. I'm gonna come back to this when we talk about Cloudbreak receives, how we use this. Okay, so right now we got an infrastructure. So we have an infrastructure, we have the Docker containers running remotely. Now the nodes can leave, so the cluster is pretty dynamic. So the next thing is you need to provision Hadoop, right? So we've been doing Hadoop provisioning over and over. We scripted, we used Ansible, we tried pretty much anything. At the end of the day, we came up with the conclusion that we're gonna stick with Apache Ambari because of the features I'm gonna mention. So at really high level, Ambari gives you a REST API and the CLI. The REST API actually is the only thing we are using. It gives you actually a very nice Ambari UI, but we are not really using it because everything we do it's automated. But the same thing you can do with the REST API, the same thing you can approach, you can do the same things with the UI, and the graphics is pretty nice. As I mentioned, we are pretty DevOps focused, and we wanted, actually our story we started just in a nutshell with Ambari Shell actually. So we started to work with Hortonworks last year. We met with them at the Hadoop Summit in Amsterdam, and Ambari had this REST API. We wanted to provision clusters, and we needed an automated way to provision these clusters. Back then, there was no Cloudbreak, there was no Periscope, there was only Ambari. So we created an Ambari, Groovy-based Ambari REST client on top of the Ambari REST API. We contributed that client back to the community. And based on that client, we created actually a CLI shell. So people don't really know, or not too many people are using, but actually if you want to provision Hadoop clusters, you don't need to use you can use a CLI shell. You can record, you provision a cluster once, and then you can always repeat that in an automated way. So there is a shell available, which we contributed back to the Ambari community. So besides provisioning, Ambari gives you other capabilities like management and monitoring. You're going to see at Cloudbreak that we rely actually quite a lot on these. And for us, the most important thing with the key feature actually at Ambari was the capability of the usage of blueprints. So you got an Ambari blueprint. So actually, I think there were a couple of Ambari sessions, I guess. Those guys most likely presented Ambari better than myself. Anyway, the main point is that blueprint is basically you list your services in a JSON file. You list your Hadoop components. This is what you want to provision. You you just throw it to Ambari server, and Ambari is going to take care and install those components and start those services on your cluster in an enterprise-ready, production-ready way, actually. There are lots of extensibility capabilities, like stacks. So by default, obviously, we've got the HDP stack, but just to give you an idea how easy to extend Ambari is, like, if you have seen yesterday at the keynote that we've been provisioning Apache Zeppelin, notebook for Spark Web UI on HDP. So actually, that's not in Ambari yet. There is no RPM for that, but you can extend Ambari. So it took us pretty much half a day, tops 1 day, to create this custom stack, which had, beside the default Ambari components, it had the Apache Zeppelin component, and we used that custom stack in order to provision the usual Ambari services plus Apache Zeppelin. Pretty neat. So if you want to write your custom service that can be pretty much anything, it doesn't have to be related to big data or whatever. You can do so with Ambari. Sorry. Services, yeah. So services pretty much are the Hadoop services. The other thing which we are not using, but actually you could use, and many people are using, our Ambari views. So for example, now we extended this stack yesterday. So we use the native UI of Zeppelin, but actually we could have pushed that inside Ambari, because Ambari gives you the notion of views, where you create your custom stack or you create your custom service, push it to Ambari, and you can create a view on top of it. And you've got one centralized place where, with the view, by the way, you're going to inherit the management and the monitoring capabilities out of the box. So it pretty much makes sense to use this feature. So with the view, you don't need to leave Ambari UI. You can actually check your health or reconfigure or do whatever with your services inside Ambari. So you don't have to go to different UIs. It makes lots of sense, for example, in an enterprise from security purposes, you don't need to replicate your user base, right? So you can, with one login into Ambari, then you can use this custom view. So how Ambari works? Again, same like Consul and Swarm. So you got an Ambari server and you got Ambari agents. So the agents are talking to the server is talking to the agent. The only thing, if you want to set up an Ambari, if you want to set up a cluster, you need to do is just define your blueprints, which is a JSON file. So you list your services. This is where your services want to run. This is my services, like HBase, Kafka, Spark. Just post it to Ambari, and Ambari is going to take care of launching these services and configuring and launching it on. The only thing you need to do, obviously, is the host mapping JSON, like on a bare metal environment or in a cloud environment. You need to specify where those services you want to run, at least on which host groups. So Ambari has the concept of host group, where you can group your services. I'm going to talk about this a bit later, but the most important thing is, like, if you got, for example, services which they do belong together, then you can put this in this logical bucket, which is called host group. And then the only thing you need to do is just create a host mapping file where you specify, like, these are the instances I want to put in this host group. So having said that, pretty much we came we fixed all these things. We went through all this process in the last 7 or 8 months, where so I think we started to work on Cloudbreak around June last year, maybe a bit later. And we came up with this project, which we called Cloudbreak, an open source Hadoop as a service API. So we've been using this internally, and we thought, like, okay, so we had this problem of provisioning clusters pretty much anywhere. Let's open source it, give it. Actually, everything we've been doing were available under an Apache 2 license, so let's give it to the community. People start contributing, people start using it. It's better for us, it's better for them as well. So this is how we came up with the product called Cloudbreak, which is, by the way, it's a surf reef break in Fiji. We are pretty keen surfers, a few of my colleagues and myself, so that's all this naming coming from. So what's Cloudbreak? So Cloudbreak is a zero configuration approach to provision Hadoop clusters. It's elastic, because of the Docker containers and because of the cloud. It's secured. We use OAuth 2 at the REST API level. At the Hadoop level, we use Kerberos. It's infrastructure agnostic, so our only dependency, we can spin up pretty much an HDP cluster anywhere. The only dependency is to have a Docker daemon running on the host, which these days any Linux distribution comes out of the box with a Docker daemon. So there were a couple of other solutions for this, not that automated like Cloudbreak, but for us the most important thing was, again, we wanted to build a heterogeneous clusters. So you got your services, you got your Ambari blueprint configured in different Ambari services configured in different host groups. Now every Hadoop service has different requires different VMs or different bare metal types, right? So Kafka might require high I/O, so you need instances which have high I/O. Spark is going to require instances with large memory. So we didn't want it to build a homogeneous clusters where all the nodes they were consisted of the same VM type or the same bare metal types or the same, for example, on OpenStack, the same VMs. So we wanted to be able to, if you got Spark on your blueprint, you can add different instance types. If you have HBase or Kafka, you can have different instance types. We provision all these instance types, and actually we make sure that the Hadoop services are going to be launched on that instance types. So you don't waste your resources, and at the end of the day, you don't waste money. Again, we wanted to add auto-scaling as well, so we wanted Cloudbreak to understand pushed in SLA policies. I'm going to talk about this at the Periscope slide. So the most important thing for the 4 most important elements of Cloudbreak are a template. Template pretty much specifies your infrastructure. So one template can be, for example, you use like a Spark template. You define your cloud provider different instance type. You define how many volumes you want to attach, what's the size of the volume you want to attach. You can configure VPC and stuff like that. So that's a template. Obviously, one Hadoop cluster can be consisted of multiple templates. So can a master host group, obviously, or where you put your name node. You don't want to be the same instance. You don't have to use the same instance size like a MapReduce node. So we allow you to put different templates in your Hadoop cluster. Stack, pretty much the stack is the infrastructure. So this is the infrastructure where the Hadoop service, the Hadoop cluster is going to be launched. A blueprint, now that's the Ambari blueprint, so there is no custom thing in the blueprint. Actually, blueprints are quite extensible, so if you want to add any custom stuff, you can push in custom configuration as well. So that's the blueprint, and the last thing is the cluster, which is pretty much the Hadoop cluster. Okay. So how Cloudbreak works? So the first thing Cloudbreak needs to do is needs to start a VM on a cloud provider. So the Cloudbreak application, which you can use our hosted solution, you can deploy. Actually, we encourage everybody to take the Cloudbreak, download the Cloudbreak application, deploy it locally. It's automated, so you can deploy your cluster. You can deploy the Cloudbreak application wherever you want on your laptop or in the cloud or any bare metal. So you take the Cloudbreak application. Cloudbreak is going to talk to your cloud provider to spin up, to start the VMs. So that's the only thing, as I said, the only thing we need is that that VM, which actually we're going to talk with, has to have a Docker daemon running. Then there is a bootstrapping process where we launch and configure this infrastructure. So in order to obviously to build a dynamic cluster, we have to have a console cluster for the service discovery, service registry, and the other features. And once the console cluster is up and running, then we need to build a Swarm cluster. Swarm is going to use as a discovery mechanism console. So these are the dependent steps. So Swarm is using console, Cloudbreak is going to use console actually at the end, Hadoop is using console because we register all the services, but the console cluster is one of the most important things for us. So once the infrastructure is up and running, basically the last remaining stuff is we start our Ambari Docker container through Swarm API. So we Cloudbreak talks to Swarm and say, yeah, launch these containers here, here, here. This is a server container, launch it there. The containers are going to be launched. Again, we don't configure anything beforehand. So what we are doing is like, how do you know like where your Ambari service is, where your Ambari server is running? How do you know where your resource manager is running or any Hadoop component is running? Usually you would need to configure. Actually, we don't care. We don't care because we use a plugin which we call it Registrator, which is listening on the socket, the Docker socket. And once you spin up a container, we're gonna know instantly what services are running on those containers, and those services gets registered in console. So dynamically, everybody's gonna know once a Docker container comes up with a set of services anywhere, we don't care. It gets registered in console, and if somebody wants to use that service, he just checks console. Yeah, where is this service running? Console is going to give him the answer. That service is running there. If that service or that container for some particular reason fails, console gives us the health check and it reports back, hey, this service actually you are about to use now, the health check of this service is not so good. We try to relaunch the container. That's a nice thing with Docker is that basically restarting a container takes milliseconds. We do a retry like 3 times, for example. If that service is still unhealthy, then we can move that container to a different host because we suspect that either there is a networking problem with the host or there is some problem on that VM or that host. It gets moved. That's another nice feature with Docker. You can move services, you can move containers actually across your setup. So now you got the Ambari server, the Ambari cluster running. So you got a services, you got a server running, you got the agent running. It's registered. The last final thing you need to do actually, Cloudbreak posts the blueprint to Ambari server. Ambari server instructs the agents install these components based on the host group's configurations, which we dynamically fill. You won't see anything from the Cloudbreak API. You won't see anything what's happening behind the scenes. So everything which I was explaining here is basically it's automated. It happens behind the scene. So a couple of features of Cloudbreak. So obviously we've been building a multi-tenant cluster, so we needed a Kerberized cluster. So anybody who did configure Kerberos on a Hadoop cluster before Ambari 2.0, I think had fun, I guess. Ambari 2.0 now fixed this problem, so you can provide you can Kerberize your cluster with Ambari 2.0. This is exactly what we are using on Cloudbreak. We use the features of Ambari. We Dockerized a KBC server, so we put along your cluster, so you don't have to care. Pretty much with Cloudbreak, with a push of a button, or actually it's a checkbox, your full cloud Hadoop cluster is going to be Kerberized. You don't need to worry about anything. We're gonna install the server. We're gonna push the key tabs at the appropriate locations. Everything is done. It's neat. The other feature is we have built its Cloudbreak recipes. So obviously, Ambari gives you lots of features of configurations, which you can configure the services. But many times there are in a Hadoop cluster, especially in a production Hadoop cluster, you need to configure lots of things on the host, ulimits, whatever configurations. So these are configurations which are either pre-Ambari or post-Ambari configurations. So we came up with this feature of Cloudbreak recipes where you can automate this whole host configuration in a way through Cloudbreak, where you can hook into your Ambari lifecycle in the pre-Ambari lifecycles, and you can pretty much do anything either on the host, on the container, or reconfigure things dynamically. There is by default, Cloudbreak comes with PAM plugin, which allows you to install any plugin. So that's the default one. Using that, you can reconfigure services. You can do something on the host, as I said, or container. or you can install your own plugins. You can specify like a GitHub location, and that plugin is going to pull the new plugin and then gets registered. We use actually a framework which is called plugin with Docker, and console takes part in this as well. You can specify with labels like I want to execute something only on these hosts. I want to execute something on those hosts. Like for example, on host groups, you want to do something on the master host group, for instance. All this is possible through Cloudbreak recipes. There were a couple of side effects. Actually, there are lots of side effects. So if you check our GitHub, you're gonna see around 200 repositories. But the most important side effects are alongside. So we have created lots of projects in order to get Cloudbreak worked, and open sourced is obviously the Ambari CLI shell and the Ambari Groovy REST client. So if you want to talk with Ambari from Java or any JVM-based language, you can use that. As I said, we are using OAuth 2. And so we need an identity server which is going to issue the tokens. So all Cloudbreak REST API calls are actually secured. You need to have an OAuth 2 token. So if you don't, you can use an OAuth identity server like Google, or you can plug in, for example, you can use Keystone from OpenStack, or if you got your custom identity server which is able to come up with a proper OAuth 2 token, you can use that. Obviously, we didn't have any of this, so we use CloudFoundry's UAA, which is CloudFoundry's identity server, which we Dockerized. We learned from the CloudFoundry guys that actually there are not too many people in the whole world who actually is using this UAA beside us. They are using the CloudFoundry hosted solution, so they were extremely happy that we Dockerized this and made it available. The other project which is pretty important is one project which we called Münchhausen. So I guess this was a guy who liked to lie quite a lot, and once he said that he pulled himself out from the mud from his hair. So this is actually we are doing with when we are bootstrapping a Cloudbreak cluster. So in order to bootstrap a Cloudbreak cluster, you need to have Swarm in order to talk. So Cloudbreak needs to talk to Swarm, but Swarm requires console, but console runs in Docker container. So there's a chicken and egg problem. So we came up with a problem with a project which is called Münchhausen, and it actually can use console and Swarm, console as a discovery service for Swarm seamlessly. So this is a pretty big problem which we fixed. Obviously, again, there is another side effect. So we Dockerized pretty much the full Hadoop ecosystem. Most likely a few of you are already using these containers. These are quite popular. So like, for example, the Apache Hadoop container, the default HDFS yarn container has been downloaded from the Docker registry more than 40,000 times. The Ambari, it's used, I think currently it's around 9,000. Spark is extremely popular, so our Spark container has been downloaded more than 6,000 times. So we Dockerized pretty much the whole Hadoop ecosystem, and people are using this. This is just one side effect of Cloudbreak. So what we've got right now, so currently on our hosted solution, or if you take the Cloudbreak code base and deploy it locally, it's gonna give you a Hadoop as a service API, a seamless API without across Microsoft Azure, AWS, Google Cloud, and OpenStack. So this is what you got right now. We did lots of R&D with other cloud providers. What has been already basically researched and development effort has been put into is Rackspace and HP public cloud. But the most important thing is that actually, because we switched to Swarm recently, you are going to be able to provision HDP clusters or Hadoop clusters on bare metal in an automated way. So use the Cloudbreak. You won't need to do anything. You got your hardware laid out. You got your network configured. After that, the only thing you need to care is to have a Linux distribution running which does support Docker. And Cloudbreak API is going to be able to instruct launch those containers and those bare metal machines and configure your cluster in a couple of minutes. Like usually in a cloud provider, so for example on Google Cloud or Azure or whatever cloud you choose, we provision. So for example, our Jenkins job starts like a 200 node cluster in 7-8 minutes. And that's a full Hadoop stack and all the services. And then so that's it's pretty cool, I guess. So obviously we were a startup and we needed to save costs, and we had to launch 1,000 node clusters, but obviously we needed to shrink up and down this cluster. So we came up with this project which we call it Periscope. Again, Periscope is a reef break in Sumbawa. All our project names are based on our surf reef breaks. So this is initially Periscope. What we wanted to fix with Periscope is we wanted to create a quality of service for running Hadoop applications. So we contributed code to Apache Yarn in order to be able to move applications. So you had a fixed size clusters, you got a couple of concurrent applications fighting for resources. You configure your capacity scheduler queues. Still, you wanted to if you saw that something goes wrong, we wanted to give priorities to applications and move applications between queues. So this is one thing. This was one stuff how we started. So okay, let's give some SLA to these applications. But then, okay, so you still had fixed resources. So if that SLA, you can't meet that SLA, you can't do anything. Either punish more and more the other applications, but after one point in time, you can punish all the other running applications. If your resources are not enough, your job is not going to finish in time. So what you need to do, add more nodes into the cluster. So this is actually what Periscope does. Okay, the most important thing for us was we don't want to ask people to install anything on your Hadoop cluster. We wanted to come up with a zero configuration approach. Have something which actually understands the running applications and understands the state of your Hadoop cluster, and you can configure something, and then based on those things, you have SLA policies. So Periscope does support metric and time-based alerts. So you can configure a cluster from 6 p.m. shrink it down, 8 a.m. in the morning, shrink it up. So that's the time-based alert. And you can have metric-based alerts. Again, before Ambari 2.0, we've been using our own alerting system. We've been pulling all the Hadoop metrics, around 400 metrics from the timeline server for the resource manager from Ambari. So we've been constantly interrogating, talking with these guys. Now, Ambari 2.0 introduced an extremely nice feature, the alerts. So you can by default, Ambari understands the services you run in your cluster and knows what kind of alerts can be or are allocated, associated those services. And through the alerts interface, actually you can inquire that. You can configure different thresholds for these metrics which are coming out of Ambari, and this is actually what Periscope does. Again, Periscope is using GoAuth 2 for security, same as CloudBreak. And you got a heterogeneous Hadoop cluster, and for example, your Spark nodes are scaling out. You don't want to scale all the nodes in the clusters. You don't want to scale nodes which are running, for example, Storm or which are running HBase, because actually you've got problem only with your Spark in services. So Periscope allows you to scale only. It's host group specific, so you can scale actually services. So if you got a Wise, if you got a good Ambari blueprint, you did some good pre-architecture beforehand, then actually this is a nice feature which you can scale only based on services. The most important components are the clusters. Obviously, that's a Hadoop cluster. You got the alerts, which right now we are pulling out from Ambari. As I said, we are pulling out around 400 metrics, so pretty much you can specify SLA scaling policies based on any metrics. So for example, if you are running out of HDFS nodes, space on the HDFS, you can configure an SLA policy to add data nodes. Your application is running out, you've got too many pending containers, you can add other kind of nodes. All these alerts are coming out from Ambari 2.0. Ambari also allows you to add custom alerts, which we already did, so we got a couple of customers. Cloudbreak actually pushes into Periscope, and Periscope pushes into Ambari, our custom alerts. So again, Ambari, it's extensible, so you don't need to think only about UI. Actually, the REST API allows you to do lots of things. Policies, that's, yeah, these are the SLA scaling policies, which I did mention. So you can set up policies based on these alerts. And then you got the applications. So the application stuff is this is the contribution which we did to Yarn. So you have concurrent applications. You can actually start moving applications between queues at runtime. So how Periscope works? Yeah, pretty much, I guess I said everything. So it configures and monitors the Ambari alerts. Now you've got a cluster which can scale up and down. We introduced a feature which is called the cooldown period. So you can lock between two scaling policies. You can actually have a time frame where the cluster is locked. So you can lock your cluster not to be able to scale up and down for 10 minutes or 30 minutes. Also, you can configure with Periscope that whatever is the scaling policy or whatever is the alert, you don't want to upscale or downscale the clusters. You don't want to lose. So you can set a minimum number of nodes and a maximum number of nodes in order to manage your cluster size. Yeah, you can set the SLA policies. And once these alerts are coming out from Ambari, Periscope understands, and you got a scaling policy associated, then instructs Cloudbreak to add seamlessly to add X number of nodes. The process is again the same: spins up the VMs or spin up the VMs on these cloud providers, instructs talks to Docker daemon, start the appropriate containers. They are gonna join the console, service registry, and then they're gonna join the Hadoop cluster. Everything actually is orchestrated by Ambari and Cloudbreak. Oh, that's it. Think if there is I want to do a demo quickly because I think there is some time left, or no? I'm not sure. Okay, then let's stick to the, sorry about that. Let's stick to QA. Whatever, doesn't work. Okay, questions? Yeah.
They have their own network.
No, we use so we launch it with a net equal host. So we've been experimenting with the bridge networks. We've been playing with OpenVis, which well, at the end of the day, from our perspective, from Hadoop perspective, the most important thing which does matter is the number of Yarn containers. So if I have on one host, I have a set of physical resources which I can't change. So even if I launch 6 Hadoop containers on that host, at the end of the day, I'm going to get the same number of Yarn containers, and the Yarn containers are doing the actual work, but I'm going to inherit the overhead of the bridge network. So the Linux bridge, currently what we have measured, if we would start multiple containers on the same host, adds around 20% performance degrees. Yeah, so we lose 20% in that. So the short answer is net equal host.
Will it deploy to boot to Docker or in any other way to a single machine solution, or is it only to cloud providers?
So for the boot to Docker, actually, if you go to Ambari, to the Apache repository, our Ambari shell, actually there is a way where you can launch Hadoop clusters in boot to Docker using the Ambari shell. So for that, you don't need Cloudbreak. This feature actually is in Ambari for more than half a year. Nobody is using, I guess, but us. But we are launching, so while we are developing, we are provisioning 6, 7 nodes Hadoop clusters on our own MacBook running inside boot to Docker. So that feature is already there. So you just take a blueprint, you use Ambari shell, you post the blueprint, and you're going to have a Hadoop cluster with the services which you have configured in a blueprint in your MacBook. And the same container, actually, it's exactly the same container which we are using in Cloudbreak in any environment. So that's the whole beauty of Docker. So the same container which we are using on boot to Docker or on a Linux or in a VM or in a cloud,
the same. It's just that you're deploying it with Ambari in the one case and boot to Docker in the other, and CloudBreak in the other.
Yeah, CloudBreak to the cloud and bare metal in Ambari shell. Yeah, with Ambari shell, actually, you can do it anywhere. But there is an Ambari Docker container which we did, and that deploys to boot to Docker. Any other questions? Okay. Thank you. Thank you for coming.